to change this here. If the probability of A and B equals 0, there's a name for this. We call them mutually exclusive. They have nothing in common. Those circles would not overlap. They can't happen at the same time. And so our formula just becomes this. Because this part of our formula, the minus probability of A and B, doesn't matter because it's equal to 0. So I don't mind. I actually encourage people to always use the addition formula, because even though that doesn't matter in this case, you can just write minus 0 and it will work out to be the same. So if you don't want to overload yourself with, oh, I'm going to memorize a bunch of formulas, the addition rule always works. And whenever two events are mutually exclusive, well, that minus probability of A and B will just be minus 0 when you write it in, and it's not really that. It's not like, oh, did I waste so much time writing that down? No, not really. But this is the new simplified formula. So when you see it this way, you go, oh, they don't intersect. There is no overlap. So card is drawn at random from an ordinary pack of 52 cards. Find the probability is an ace or a king. Again, in this situation, you would probably just visualize it in your head. How many aces are there? 4. How many kings are there? 4. What are the chances of getting an ace or a king? There's 8 of them out of 52. Now, if we wanted to go to our formula, our addition formula says, what's the probability of an ace or a king? Well, I'd figure out the probability of ace plus the probability of a king. And even if I write out the probability of ace and king, this is 4 out of 52. This is 4 out of 52. And now there is none that are both. You can't pull out the ace of kings. Just doesn't happen. And so you still get 8 out of 52 that way. So there are some practice questions that you can do.